Hello guys, how are you? I hope everything is good. We have question 91. The question says, the reading of the voltmeter in the opposite circuit is 12 volt. Okay, what will be the voltmeter reading if the diode is reversed? Okay, they're asking if we reverse this diode, okay, how will the voltmeter reading change? Okay, let's start. Okay, I will change the color here. Okay, now the reading of the voltmeter, okay, the V, let's name it V1. Okay, just to differentiate between the three resistors, and here R1. Okay, the V1 is going to be R1, which is 2 ohm, multiple the current in the circuit. Okay, multiple the current in the circuit. Okay, the current, I don't have it. Okay, how to find the current in the circuit? The current in the circuit is actually equals to the electromotive force of the battery divided by the total resistance. Remember, the total resistance after reversing the diode. We're going to discuss this. The electromotive force, I don't have it. And the total resistance after reversing, I don't have it. Okay, so I'm going to find each one of them, E and R total. Okay, I'm going to keep this area here empty. I'm going to this side under the diagram to discuss each one in details. Okay, now we need to work with the circuit before reversing the diode. Okay, I can find the current and I can find the electromotive force. How to find the current? Notice the current goes from the positive side of the circuit, from here. It goes here. It goes through the two parts. Okay, it goes here and here. Okay, again, it will go, all of it, all the current will go into R1. Okay, so I can say that current is actually V1, the reading of the voltmeter, divided by R1. Remember, here we are solving before reversing. Okay, before reversing. Here in this side it's after. Okay, so the current is 12 by 2, which is 6 ampere. Okay, now I found the current. Why did I find the current? Is it the same current as here? No, it's not, because the current here, the 6 ampere, it's before reversing the diode. Okay, now I'm going to explain to you what does it mean if we inverse the diode. Let me just here complete to find the electromotive force of the battery. In order to find the electromotive force of the battery, here E is going to be the current multiplied by the total resistance. Okay, the total resistance before reversing. Okay, now let's find the total resistance, R. I want you to pay attention. I have two resistors connected in parallel, the 2 ohm, and this parallel combination is connected in series with this one. Okay, so I can simply say, I hope that you follow me, 1 by 2 plus 1 by 2 minus 1. This is the total for the parallel combination, and then I add the series. Okay, which means R total, okay, equals to 1 plus 2, it is 3 ohm. Okay, This is the total resistance. Now I can find the electromotive force. Let me change the color. Okay, the electromotive force is going to be here, from here. It's here. Okay, so the I, we found it 6. Okay, so 6 multiple the R total is 3 equals to 18 volt. You may ask me, Mr., why are you doing all this? Why are we finding the electromotive force? I want you to pay attention that the electromotive force doesn't change because we are not changing the battery. Okay, so before and after, the electromotive force doesn't change, which means I can say that here, now I know, let me erase, now I know it. Okay, it equals to 18 volt. Okay, that's why I went to the right side and found it. Okay, okay, now let's explain what happens when we reverse the diode. Let me erase these things here. Okay, now I'm going to erase this one, sorry. Okay, just stay with me for a while, please. Okay, I'm going to draw over it with black. Good. Okay, it became here, and here is the diode. Okay, so we reverse the diode. The current comes from here, it goes in this part, but when it goes in this part, it will not move because the diode will not allow it. So we can say that this part is deleted, like there is no resistance in this part. Okay, so after reversing, let me erase them with the white color here. Erase everything here. Okay, so after reversing the diode, it's like this part doesn't exist. Okay, so this is the circuit after reversing. Okay, what does that mean? It means in this side, if I want to find the total resistance, it's actually for this resistance and for this resistance, which we named it R1, and here is going to be R2, which, as you can see, they are on the same line. They are on the same line, connected in series. So the total resistance here is going to be RTO is going to be 2 plus 2 equals to 4 ohm. Okay, now I can find the current, okay, after reversing. The current is 18 over 4, which is it's like 9 over 2, it's 4.5 ampere. Okay, I found the current to substitute it in here. They are asking me to find the reading of the ammeter. So V1 equals to R1, which is 2, multiple 4.5, which equals to 9 volt. Okay, so the answer is D. For some students, they will say, Mr., it's a long problem. How am I going to do this? This type of problems, you can solve them easily, okay? First of all, by reading the question carefully. You have to differentiate between before reversing and after reversing, okay? And you have to pay attention, what do they want exactly? They want here the reading of the voltmeter after they reverse the diode, okay? And by practicing, okay, and by paying attention to each step, you can solve this type of questions easily. Okay, sorry this video is long. I hope that you understood the question. Feel free to watch it again, and remember, always try to solve the question by yourself before watching the solution. Okay, have a good day. Bye bye.